This is Jacob Camp from Leister Technologies, doing a demonstration today of our WSAT turnkey laser plastic welding system. This system is currently equipped with a spot optic head, 200 millimeter focal lens. It's a diode laser that has the capability of powers up to 200 watts. What I can do right now is actually show you the part. So here's what we're welding. We have this top part that's transmissive to the laser, and then this bottom part which is absorbent to the laser. We're going to weld on this inner weld seam as well as the outer weld seam. So what I can do now, since the application is already set up, is put it in our fixture. And soon you're going to see, once I press these two buttons, you're going to see the drawer move in, the safety door is going to slide down, then the clamping glass is going to clamp down the parts to ensure intimate contact during welding, and then the optic head, which you see right here, will actually traverse the weld path that we want to take both on the inside and outside welds, as has been programmed using the GCode in our Leister HMI. So here we go. And now you can see the finished part. You see there's no flash. It's a very clean, precise, repeatable process. It's also a very strong weld. These parts have already passed drop tests just to prove the strength of the weld. So this is a completed part welded in Leister's WSAT turnkey laser plastic welding system. What you can see here, if you zoom in closely, you can actually see the weld contours, both the inner one and the outer one. And what we've done, just to illustrate the strength of this weld, is we've cut one of the previously welded parts in two. So here you can see, we just sawed in half. You can see the inner weld seam and the outer weld seam. You can even see there where the two materials diffused into each other. And also what we did with the other half of this part was that we pried off the top transmissive layer. And here you can see all this material transfer of the transmissive layer onto the absorbent layer. And this is a sign of a very good weld, because you can tell that the material broke before the weld did, meaning the weld is actually stronger than the material itself. With laser welding, it is very easy to go from a 3D model of your part to a 2D DXF file of the weld region, and then to import that, or to convert it to GCode using Leister's DXF to GCode program. So once you've taken a cross-section of your 3D CAD file and converted it into a 2D DXF file, all you need to do is import the DXF file into DXF to GCode, and that will create the GCode necessary to instruct the optic head to move along a particular path in order to create the weld. So you can see here that's already been done. Here on the left side you see the GCode, and on the right side you see actually a visualization of what the travel path of the optic head will be. You can even make changes to the GCode, and those changes will be reflected in this window to the right. So once you have a program, there are a few other variables to consider. First is the speed of the weld. That can be changed at any time just by a command starting with F, and the number after F is the speed of the travel speed of the optic head in millimeters per minute. So you see here we're moving at 6,000 millimeters per minute, 100 millimeters per second. Another key parameter, of course, is the laser power. There are several options for controlling laser power, but the simplest one is fixed laser powers, where you simply set the laser power that you want, and you can actually choose up to 4 different laser powers in the program. You can simply change the power by typing the power you want to switch to at any time at any point in this GCode program. And finally, the third key parameter is the clamping pressure. You need to make sure that you have enough clamping pressure on the parts to ensure intimate contact during welding. The necessary clamping pressure can change depending on the material itself and also the geometry of the part. Previously, you were shown the welding of a battery housing using contour welding. And this is only one of the many welding options that Leister offers. For example, we have, instead of a contour welding system, we have the option of a scanner system where rather than the optic head itself moving, the optic head is stationary, but mirrors inside of the scanner move around in order to move the laser. This can be used in situations, for example, when you want collapse of the materials, as that collapse can be closely monitored, and then when the collapse reaches a certain value, the welding can be stopped. Another advantage of this method is that you can go extremely fast, up to 10 meters per second, and that enables you to do multiple cycles in rapid succession. That's why it's called quasi-simultaneous welding, because it's almost as though the entire weld region is being welded at once.